In this video, we're going to talk about how to find the LCM and HCF of the set of numbers. We already have examples on the screen, so to start off, I'll simply write solution. For the first example, we are told to find the LCM and HCF of 10 and 15. For me to find LCM and HCF, I have to rewrite these numbers in terms of prime numbers. Now, if you're not familiar with prime numbers are numbers that can only be divided by 1 and itself. So examples of this kind of numbers is 2, 3, 5, 7, 11, 13, and so on. Now, my first step would be to express 10 as a multiplication of these numbers here and 15 as a multiplication of these numbers. For me to do that, I'll break 10 down till it gets to 1. So I'll say 10 here. So I ask myself, what is the smallest prime number that can go into 10? The smallest prime number that can go into 10 is 2. So I'll say 10 divided by 2, that is 5. The smallest prime number that can go into 5 here is 5. So 5 divided by 5 is 1. Now that I've gotten to 1, I can stop my whole process. So that if I say 2 times 5, it still gives me 10. So I can write 10 as equal to 2 times 5. Next up, I move to 15. So for 15, I still do the same process. Ask myself, what's the smallest prime number that can go into 15? So the smallest prime number that can go into 15 is 3. So 15 divided by 3 is 5. The smallest prime number that can go into 5 is 5. 5 divided by 5 is 1. I'll multiply all the numbers here. Should give me back 15. So 15 can be written as equal to 3 times 5. Now, what I'll do for both of them is I'll take the number of times each prime number appears. So 2 appears here once. So I'll say 2 to the power of 1 times. 5 appears here 1 times. So I'll say 5, then I'll give it the power of 1. For here, 3 appears here once. So I'll say 3, I'll give it a power of 1. 5 appears here once. So I'll say times 5, I'll give it the power of 1. Now from this point, for me to get my LCM, one of the first things I will do is that I'll pick out the prime numbers that are available here. So the prime numbers that I have for the two numbers is 2, 3, and 5. For me to get my LCM, I'll search the 2 that has the highest power on both 10 and 15. So if I go here, the highest power of 2 that I can see here is 2 to the power of 1. If I go here, I cannot see any power of 2. So I'll write the highest power of 2 that I can see, which is 2 to the power of 1 times. I'll go to the next number, which is 3. Then I'll find the highest power of 3 that I can see on these two sides. So the highest power of 3 that I can see is this one, 3 to the power of 1. So for the next number I have at my disposal, which is 5, I'll check for the highest power of 5 that I can find. So the highest power of 5 that I can find here is 5 to the power of 1 here and 5 to the power of 1 here. Since they are equal, I'll simply pick 5 to the power of 1. So this will be 5 to the power of 1. From here, if I expand these numbers, they are in 1, 1, 1s. But if I say 2 times 3 times 5, 2 times 3 is 6 times 5, that is equal to 30. So the LCM of 10 and 15 is 30. For the HCF, I'll be looking for prime numbers that appear in both 10 and 15. So if I look at prime number of 2, it only appears in 10, but it doesn't appear in 15, so I'll leave it out. If I look at 3, 3 appears in 15, but it doesn't appear in 10, so I'll leave it out. If I look at 5, 5 appears in 10 and it appears in 15. So now I'll pick the one that has the smallest number of appearances. Both of them have the same number of appearances, which is 1. So I'll just simply say 5 to the power of 1. 5 to the power of 1 is 5. So the HCF here is 5. The LCM here is 30. Let's look at the second example to help you get familiar with LCMs and HCFs. So for the second example, we are told to find the LCM and HCF of 20, 15, and 30. So the first number we have, let's write out 20, and then we break it down. So 20, The smallest prime number that can go into 20 here is 2. So 20 divided by 2 here is 10. The same thing, smallest prime number that can go into 20 here is 2. 10 divided by 2 is 5. Smallest prime number that can go into 5 here is 5. 5 divided by 5 is 1. Now that we've gotten to 1, we can pick all the numbers here and multiply them to give us 20. So that 20 is equal to 2 times 2 times 5. This is equal to, since 2 occurs 2 times here, we write 2 to the power of 2 here times 5. Now the next number that we have in our hands is 15. So this is equal to, if I have 15 here, the smallest prime number that can go into 15 here is 3. 15 divided by 3 is 5. 5 here, we have 1. Now we've gotten to 1, so we pick the numbers here. That is 3 times 5. By the way, this is 5 to the power of 1. 5 appears here once, so this is equal to 3 to the power of 1 times 5 to the power of 1. The next number is 30. So for 30, let me create another table here. For 30, smallest number that can go into 30 here is 2. I have 15 here. 30 divided by 2 is 15. Smallest number that can go into 15 here is 3. So I have 5 here. Smallest number that can go into 5 here is 5. So I have 1 here. Now pick all the numbers here. So I have this as equal to 2 times 3 times 5. This is equal to 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 1. For my LCM, the prime numbers I have for 20, 15, and 30 is 2, 3, and 5. Those are the numbers that appeared here and here and here. First of all, I go to number 2. Then I check which one has the highest powers of number 2. So if I look at number 2 here, we have 2 to the power of 2. There's no 2 here. But we have 2 to the power of 1 here. Now I'll pick the one that has the highest power. So I'll be picking 2 to the power of 2. This will be 2 to the power of 2 times. I go to my next number, 3. Now there's no 3 here, but there's a 3 here, 3 to the power of 1. And there's a 3 here, 3 to the power of 1. Since they have the same powers, I can just pick 3 to the power of 1. This will be 3 to the power of 1 times. Then I go to 5. So here I have 5 to the power of 1. Here I have 5 to the power of 1. Here I have 5 to the power of 1. I will just pick 5 to the power of 1 since all of them are the same powers. This will be 5 to the power of 1. If I expand this, this will be 2 times 2 times 3 times 5. 2 times 2 is 4 times 3, 12 times 5. This is equal to 60. So the LCM is equal to 60. Now the HCF is equal to, I'll go to my prime numbers again. So I'll look at 2 and check whether it appears on every side before I pick it. 2 appears here, but it doesn't appear here. And it appears here. Since it doesn't appear here, I'll leave out 2. Now I'll go to 3. 3 doesn't appear here, but it appears here and it appears here. Since it doesn't appear here, I'll leave out 3. Now if I go to 5, 5 appears here and it appears here and it appears here. So my next step is to check which one has the lowest power of 5. There's a 5 to the power of 1 here, there's a 5 to the power of 1 here, there's a 5 to the power of 1 here. So all of them are the same powers. I'll simply just pick 5 to the power of 1. So this 5 to the power of 1 is equal to 5. The HCF here is 5. Let's take one last example to wrap up LCM and HCFs. So for the last example, we are told to find the HCF and LCM of 50, 30, and 8. Like we did before, we write each of the terms as a multiple of prime numbers. So we have 50 here, 30 here, we have 8 here. Starting from 50, breaking it down, I have 50 here. And the smallest prime number that can go into this is 2. 50 divided by 2 is 25. Smallest prime number that can go into this is 5. So I have 5 here. Smallest prime number here is 5. Then I have 1 here. So I'll pick the numbers here so that this is 2 times 5 times 5. This is equal to 2 to the power of 1 times 5 to the power of 2. For 30, the smallest number that can go into 30 here is 2. 30 divided by 2 is 15. 15 divided by 3 is 5. 5 here is 1. So for 30, we have these three numbers. So this is 2 times 3 times 5, which is 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 1. Then for 8, I have 8 here. The smallest prime number that can go into this is 2. 8 divided by 2 is 4. Smallest prime number that can go into this, 2. 4 divided by 2 is 2. And then smallest is 2 still. So that I have 1 here. So I can stop and pick this 3. Here I have 2 times 2 times 2, which is equal to 2 to the power of 3. The prime numbers I have repeating here is 2, 3, and 5. So for my LCM, I have, if I go to the number of 2, I search for the one that has the highest power of 2 across all these numbers. So the one that has the highest power of 2 is 2 to the power of 1, 2 to the power of 1, 2 to the power of 3. So I'll pick 2 to the power of 3. This 2 to the power of 3 times. I go to my next prime number, which is 3. I'll check for the one that has the highest power of 3. There's no power of 3 here. There's a 3 here. This is 3 to the power of 1. There's no 3 here. So I'll simply pick the 3 to the power of 1. This will be 3 to the power of 1 times. The next number is 5. Here I have 5 to the power of 2. Here I have 5 to the power of 1. Here I do not have a 5. So I pick the highest one, which is 5 to the power of 2. This is 5 to the power of 2. Now this should be equal to, if I expand this, I have 2 times 2 times 2 times 3 times 5 times 5. Now if you use a calculator to do 2 times 2 times 2 times 3 times 5 times 5, you get this as equal to 600. So the LCM here is equal to 600. Now for the HCF is equal to, I go back to my key prime numbers. So the first prime number, I have to check whether it appears on every side. So here 2 appears on once here, 2 appears once here, 2 appears 3 times here. So my aim is to pick the one that appears the lowest. So 2 appears once here, and 2 appears once here, 2 appears 3 times here. 2 appearing 1 times is the lowest. So this will be 2 to the power of 1. Now for my next prime number, I check whether it appears everywhere first. 3 doesn't appear here. 3 appears here, but 3 doesn't appear here. So I leave out 3. My last number is 5. 5 appears here. 5 appears here, but 5 doesn't appear here. So I leave out 5. So that means my HCF is equal to 2. That's how to find LCM and HCF for a set of numbers. If you like the video, give it a thumbs up, share with your friends, and subscribe to the channel. Thanks for watching.